Hey, Professor Cunnington. This is Gerard. I'm here to do the algorithms analysis. Um, Once again, I'm doing a video just because I like to be personable and I can convey my ideas and thoughts a little bit more clearly than I can on writing assignment. If you do need a writing assignment though, or a write up for something, let me know. I will, by all means, do something a little bit more in a formal manner if this is not acceptable. Um, But here, basically, what I'm getting from this is it's just teaching us how to really kind of look at what our program's doing. The program or algorithms analysis. So I chose the C++ program that I used that takes um, a a set of words that the user wants and loads it to a file and saves it as a text file, then reloads it back into the program into a vector, uh, which is compared to another vector which has some preloaded um, files in it as well, such as like a romance novel or a little blurb from a comedy, a couple different genres, and then also the ability to also make your own story, save it to a file, reload it, and load it to a vector, and compares it. And basically, what it's doing is I would like to find the word a, or the word water, love, the, if, then, gold, and compares it to the little um, bit of text that you have and tells you how many times that word appears. So um, this is this was with Professor Hinton in his C++ class, and so this is the one that's it's not too complicated, but I think it's just the right amount of complicated for this class because it does take some data structures and compare them to each other, which through some functions, which is I think a good test of what we're trying to get here. Um, I'll be 100% honest. The big O notation, it makes sense. It's a little, it's not complex, but it's a little tedious as far as learning. But I do understand what it's trying to do and what it's trying to measure. I'm just not having trouble, but it's just difficult trying to find correct ways to implicate it or what a real, I guess, what's the word I'm looking for? A real example would be, like, and obviously can be a number of things, and how it is broken down without using constants and stuff like that. Um, I understand it. It's just kind of it's hard to grasp. It's simple, but it's not. I don't know how how to explain it. But here in the tasks, we're going to determine the report of the big O for my algorithm. There's a specific one in there that I want to look at, but we can look at all the functions through this. I use Visual Studios and the profiler that it comes with. Um, what computational resources does your algorithm slash code use? Um, and so that I'm assuming it's like O n to the squared is what you're looking for and stuff like that. What resources impact the preference of your algorithm? Um, So that I'm assuming where it's pulling from as far as how many data structures or what it's actually looking at and what kind of input is getting put in there, what volume of usage is it getting, stack, heap, how many things are getting placed into it, strings, all that stuff. And then in what cases, situations, or scenarios would your algorithm performance be enhanced or diminished? Um, that we'll just go over once we get there. That's obviously improves slash unimproves. And then show the lines of sections of code that would be affected and explain why. And again, we'll just do that in code. So without further ado, let's get that down. Let's bring it up here. So I've already done the liberty of kind of bringing up some other the tests, but this is basically what it is. Basic no, I wouldn't say basic, but C Sharp. These are the dialog boxes, just to give you a hint. If you need the repository for this, just let me know so you can also look at it, unless this is good enough. And I'm going to actually zoom in so that way you can see things a little bit better, just for your own personal preference as far as viewing everything. These are the searchable words, so this is just basically just a class with a constructor and deconstructor. So all these things in here, regardless of what they're doing, will be playing in here, and I'll go into the specifics. The one function that I want to find for you is if I can find it. I'm trying to think where I put it. That's so funny. File manipulator, is it in here? Ah, yeah, okay. So display compared word results. This is basically what's actually comparing things in here. So, oh, here it is. Vector comparing function. This is the bad boy that we're going to be doing. As you can see back in here, it's vector comparing functions. Vector comparing function. All this is doing is the vector, pardon me, the vector that the file loads up to that the user makes for the searchable word. So these are the words that they want to find. Gets loaded up to one vector. We'll just call it vector, vector, what is it, y, right here, because, you know, this is basically what it's doing for looking through the strings on all this vector. So vector y is the searchable words that the user wants to find. String vector x is the list of words from the genre, and basically what it does is you pick a genre, it takes the little dialog printout and it loads each word, it looks through each word in that file and loads that then to a different vector, and then we take both vectors from x from beginning to end, and we basically just convert it all to upper, so that way there's no real issues with like capital T for the, if you want to find the, you know, and you typed it lowercase in your word search desire area. Same thing for Y. So basically everything gets converted to capitals, so that way they are uppercase, so that way you can just, makes it easier for the computer to just be like, all right, this is the word, this is the character, letter, blah blah. Then it takes each string and it strips it of punctuation. So it goes through the first vector and then finds any punctuation in the second vector, and then if they're not equal with the punctuation, it'll just strip it. So all it's going to do is increase the vector results at current index by 1. And this is going to be for count. And you can see count in a couple of different places. Count 0. This is just so... I apologize, it's late for me. This is just so that it can go through each vector in each index for each word, no matter how large or small the vector is. And then increase it by 1. And then increase count by 1, shifting the index in result up by 1 again. And that's for these, the y. So x is getting it here, and then y is getting it here. And then that's basically the function. So let's just take a look at what happens when we do this over here. So I'm using the analysis target tool that they have here. So I'm going to do CPU usage. And just for kicks, we'll do GPU usage, and we'll do start. Do you want to allow the app to make changes? Yes, I would like it to let it do things. Hopefully that doesn't do anything crazy long. Okay, so we'll just do this so that hopefully you can see what it's doing. But basically we're going to just make a file name. I'm going to just put sample, right? Let's get off caps. It doesn't really matter, you can put caps, I'm just OCD. So the file name is going to be sample, and then we're going to just put hi the it car red gold love you need face black death night. This says limit it to 10, but I just you can do anything. Let's do night with an N too. Let's just see what happens with there, and then we, right? So I made it so that you can be very versatile, but the instructions say limit it to 10, so that's the file. Basically what it's doing in there is it's going to just make the file sample with all these words, load it, and then these are just like little marks for me. Sample is created, the file open sample, and then it basically loads that right here is where it's loading it into the vector, right? So now that you've done that, you can choose one of these genres. So we'll just do sci-fi. Bam, we'll hit 1, hit it through, and then it just tells you how many times that word's inside of that little blurb, and the little blurb's right here, you know. And then so even though it's displayed here with correct formatting, you know, the indent, dots, and all that stuff, there's basically a stripped version of it that gets compared, and then there's a normal version of it that gets displayed out to the user. So then again, it just says sci-fi open.txt, your results. And then just for simplicity purposes, I'm going to just do the one. Actually, we'll do 3. We'll do romance and fantasy. So let's just do romance. So I'll hit 2. Again, it tells you how many of those are in there, and then we'll do 3. Bam. Again, it tells you right there. And then we are going to just exit. I'm not going to do the custom one because I think that could get a little complicated. Bam. Press any key to continue. And we're out. We're exiting. So it's going to do its thing right now. The Visual Studio one, I've noticed it's user-friendly, but it does take a minute sometimes. But anyway, if we go back into this area right here, let's see if I can get the whole thing in one little spot for you. Alright, so basically this whole little section right here is what I really want to focus on, because this to me is the most interesting out of the code, because it's taking 2 data structures and comparing them to each other after they've been loaded with a file, and then strings have been cut from each line, so it reads the file not line by line, but each string, and then loads it. So it was a tedious task to get there, but we did. And let's see what's the first thing. So what computational resources does your algorithm code use? Based off of what I've been reading, both from online sources, also I'm a visual learner, so I have been using YouTube. I also use Udemy. I'm using a Udemy course paired with this on data structures to also help me. And just other article readings other than the textbook. This looks like a, what was it, O to the N, not an N log N, but basically what it's doing is you have, ON squared, and just because it's got the 2 different types of data structures being compared, and even though the constants can change because of the amount of information that's being put into it, and the fact that the variables can, or the vectors can basically be dynamic lists. They can increase or decrease, be reset, all that stuff. That is what I'm thinking that this is, if I'm understanding Big O theory correctly. And so basically what that's telling me is that this will change every time based off of each input that is loaded into the list, and then the size of the list for comparison. And so this one will never really change once you've made it as far as a user, 10 words, 15 words, whatever words you have. This should always stay the same as a constant number. We'll just say like 5n, or 10n based on how many words you have in there. The one that will always start to change is this one right here, unless you do a custom one that is 10 words every single time. This is the genre, the little blurb of text that your words get compared to. And so, like the sci-fi little note is bigger than the romance one, and I think the horror one's shorter than the sci-fi one. So this one will always be changing, and hopefully we'll see that here in this bad boy. So let's see, view details. Booyah. Okay, so awesome. Here we have GPU usage. Um, let's see if we can find. It's so funny. Main was doing a lot of good stuff, but let's see if I can find it by sort. Oh, that's not what I want. I want this one. All right, there we go. CPU usage. That's what I want. All right, so CPU usage. Obviously, main's going to be the bulk of it, right? Because that's basically stack heap wise uh, memory usage. That's got everything in it, and so this effectively can't close out until everything's been resolved, right? Like stacking dishes on top of each other, you have to clean the first one before you get back to the bottom one. But the bottom one is the first dirty dish, right? That's main. Main is the first dirty dish, and then all the other dishes get stacked up, and then you have to start cleaning from the top down to get back down to finish cleaning the bottom one, which would be finishing main. But the one that I want to use as an example, and it's actually funny, I had anticipated this being a very heavy one, but it seems like out of the major functions that we have in here, vector comparing function is not that crazy. So all this is done in, let's see, percentage usage. Let's click on it. Let's see what we got going on here. I believe it's all milliseconds. But as you can see here, so each one of these is going to be body vector function. There is 36%. So the way that this is going to be used is every time that it goes through, it's going to be a linear style, or yeah, linear, logarithmic linear, or a linear style time comparison based on whichever, and that little curve will adjust based on each different loading of information into the vector. And here you can kind of see the different usages for the different samples, and each one of these is going to be begin, and so each time it goes through and it begins to load, it's going to take that much time, so 5 milliseconds, and then to allocate to the end, it's going to take 3 milliseconds. I honestly don't know what the other is, which is something else I should probably also do. But this is transforming the characters to char, because each string had to get converted to a char so that you can go through each character in each string to compare it to each. So it's a lot going on here. But it's actually not that bad if you're really looking at it as far as what's happening here. If we go back to, I want to go back to the GPU usage. And so these are nanoseconds. And if you can see here, the GPU, there's no real 3D, duh, because there's no 3D. And there's actually not even really any usage in general. I mean, it's taking, I mean, nanoseconds are nothing compared to what it could be using. But then again, it's a console. But as you can see here during the processes of, let's see if we can do the filter. I'm gonna just be honest. Probably I don't really know how to get to the point that I want to do. Still learning the Visual Studios. But I mean, basically, this style of vector comparison, I definitely think is ON squared. And then let's see what else we got. So we're determining ON squared, computational resources, code used. We're using vectors with the comparisons, and then loops, obviously, to go through each one. What resources impact your algorithm? So obviously, I've been saying it a lot here. It's the amount of strings that get loaded into and then converted to chars so that it can be compared properly. The other computational resource I would say is that it is being loaded from a file and down or loaded from a file and then put into a file, so that the fact that it has to open up and interact with other programs, I think it would also take some time. Plus, it has to read and write, which can sometimes be a little bit of a pain. Plus, you also have to remember that this is in its own little class usage. So if we can find this here, vector manipulator, bam. So this is the header for it, and I believe it is inside of the program flow. So it's definitely inside program genre selection loop, run selection, display comparison words. So in here, it's getting stacked, because these kind of play in flow with each other, and then it's in compared word results. So that's also going to take it, because not only is it referring to these classes to try and get the files that you're creating, the compared words and the genre words, but it's inside of classes that are trying to do other functions, like display the lists that you had, that you can choose different things and whatnot. And then what else do we have? In what cases, situations, scenarios would your algorithms perform the best, be enhanced or diminished? So I would say it would probably be best if, I think I really optimized it, to be honest with you. I think if there was a way to honestly um, not have it weigh so heavy on the stack, that would be the best. Or But I honestly think it did pretty well with it. I know for a fact what would cause this to not do super, super well um, would be to try and have this transform everything to uppercase, and to try and do like multiple search for all uppercase, search for all lowercase, search for like dual words. So like I wanted to search for the uppercase version of the word, the lowercase version of the word, and then the mixed versions of it. I think converting everything to one case made a huge benefit to it, as far as memory, especially inside of this function. Um, so that would be these two lines right here, bam, which are actually assigned right here, and this is the char usage right here. Oh, we went too deep, too deep. Back up. We went way too deep. But yeah, so you could see them as you highlight them. You know, man, it's being weird again. There we go. So as you go down each one of these, you'll see it highlights in red what's going on with all of these. Let's see what else we got. I'm sorry, this video is taking far too long. I will have to reorganize thoughts for the next one. Show lines of section of code that would be affected and explain why. Well, I kind of just did explain. If you were to try and actually go through each each string instead of each char here, I think it would just make it so that you would have to have too many redundancies in there. So it would be too many things, adding more to the stack. Um, and I just think that the style of that algorithm would probably be, I think it would be like 01, but it would just be too slow. And I know this isn't super great. Like n squared, I think is not, it's close to the more optimal side, but it's not the best. I think n log n is, but I just think that the the converting before and then comparing is better than having redundancies to compare to more. Um, so having more vectors, more lists, and more things added to this so that it has more things to compare to would be an overhindrance. And so that's why I think these two lines of code right here are very key and essential to this, because it basically makes everything an uppercase character so that it can be compared and then um, properly displayed afterwards after it's been counted and then compared to each other. Um, that is basically in a nutshell what I have here. Um, I might not be 100%. This definitely used I/O. Didn't use networks. Networks scare the crap out of me. The RAM usage with the processor and all that stuff, and then my CPU. But I was super surprised. I really thought for a fact that this was a pretty interesting. Um, I don't know. I guess call tree. I just thought that this was a really interesting kind of project to put this on because I like data structures, and it's weird because um, learning to code, I've used them and I've come very accustomed to specific ones, especially in C++. I love structures and I love vectors. And doing the game programming side of it, vectors are used very often for movements. Doing the AI side of it, vectors are. I like vectors over arrays. You know, the downside to the vectors is that with memory it's random, and so it has to search for it, which can take some time and CPU usage versus arrays, which are just chunks that are one right after another. But I mean, all this stuff is so very nitpicky and almost inconsequential at such the level that we've been doing it. I think this would show a lot more in a massive project, in a massive game, in a massive um, kind of environment for us to see, and it would be really awesome to kind of see that on where it makes the effect. Like I think what was it, Chris Harris or Chris or one of the students. I think it might have been Ryan. He was saying on how those milliseconds, those nanoseconds, were saving companies thousands of dollars per week, per month and stuff like that. And so I can see on how like a massive project that would have a huge effect. But on these small ones, it was really hard, and I'm sorry I don't have such a robust portfolio yet to really test an in-depth program. I'm still um, learning from scratch, but in the end, I think I understand Big O. I'm definitely excited for data structures. If you have any questions, concerns, or more requirements for me to use for this, just let me know. If you don't like this style of submission, please let me know ahead of time so that way I don't even consider it and I can just start doing something else for you. But I really like this so that way you can kind of understand train of thought. I can kind of actually express what I'm trying to tell people, and usually most people enjoy it because they get to actually start to know fellow students a little bit better. Um, Thank you for your time and have a good night.